Hi students, topic for today's discussion is pollinators. So pollination is a transfer of pollen grains from the anther to the stigma. So pollen grains are produced in the anther. Here you may see. Pollen grains are produced in the anther and they are transferred to the stigma. So this process it is known as pollination, and the agents which transfer the pollen grains from the anther, so this distance is covered. The agents which transfer the pollen grain from the anther to the stigma of same flower or different flower, a very long distance. This is covered by these agents. These are known as pollinators. So pollinators, these are the agents which transfer the pollen grains from the anthers to the stigma. They are known as pollinators. So today we are going to discuss about the pollinators. So there are different agencies for the pollination. There is a wind as a pollinator, there is a water as a pollinator, insects as a pollinators, birds as a pollinator, bat as a pollinator, snails as a pollinator. There are number of agents which act as a pollinators. But if you study them separately, then you will be confused, and therefore we have to study the pollinators as a biotic pollinators and abiotic pollinators. The abiotic pollinators, they are non-living things. The wind as a pollinator, the water as a pollinator, and biotic, they are living things. They are animals. The insect as a pollinator, the birds as a pollinator, the bats as a pollinator. So these are the biotic pollinators. So we'll discuss the pollinators under the headings abiotic pollinators and biotic pollinators. We take as a wind pollinators as a representative of abiotic and insect pollinators as a representative of biotic pollinators. We will discuss the comparative account of wind pollination and insect pollination. Here we will compare them, then you will understand all these pollinators, because the characters of water pollinators, the flowers with water pollination, they are very similar to the wind pollination, and the flowers with bird pollination or bat pollination, they are having similar characteristics of insect pollination. So we will study comparatively the wind pollination and insect pollination. Here we will study what are the adaptations in the flower, wind pollinated flower, and what are the adaptations of insect pollinated flowers. We will study them comparatively. So first point is number of flowers. So here you may see this is the grass which is having wind pollination. The grass, very small grass, but here you may observe thousands of flowers. A single plant produces thousands of flowers. So number of flowers per plant is many in wind pollination. The number of flowers per plant produced is very few in insect pollination. So Vinca rosea, so this or Catharanthus roseus Sadafuli plant, this plant will take as an example of an insect pollinated plant, and grass as an example of the wind pollination. Size of flower, they are very small, and the insect pollinated flowers, they are larger in size. So here number is many, size is small. Number is few, size is large. Then about these devices we'll study color, nectar and scent. These are the devices to attract the pollinators, to attract the insects for the pollination, and these devices, they are present in insect pollinated flowers. Colors present, variously colored, so here you may observe flowers are colored. Nectar present, scent present. But here in wind pollinated flower, there is no need to attract the wind, therefore color is absent. Here you may see color is absent, there is no nectar, there is no scent. Then about the stigma, character of stigma. Stigma is feather like in wind pollinated flowers, while stigma is solid in insect pollinated flowers. Then number of ovules per flower, 1 to few. Number of ovules per flower, 1 to many ovules may be present. Then about the pollen size, less variable. All the grasses, they are having similar size of pollen grains, but here in insect pollinated flowers the size is variable. So according to size of insect, according to size of pollinator, the pollen grain size is also variable. Very small pollen grains may be present, small pollen grains may be present, medium sized pollen grains may be present, large sized pollen grains may be present, very large sized pollen grains may be present, gigantic pollen grains may be. So size is variable according to the size of pollinator. The size is variable in insect pollinated flower. Pollen grain size is variable. Here less variations occur. Pollen numbers, pollen grain number, here in grasses or in wind pollination, pollen number is many because wind has no idea about the stigma. Therefore the pollen grains are wasted, and therefore the pollen grains are produced in large number. In insect pollination, the pollen grains are produced in less number. Then about the pollen ornamentation. Pollen ornamentation present in insect pollinated because the pollen grain is ornamented, and this ornamentation is useful to attach the attachment of the pollen grain to the insect body, and therefore the pollen grains is variously ornamented. Here there is no need of attachment of pollen grain towards the wind, and therefore the pollen grain is smooth. It is having no ornamentation. Pollen grain wall is smooth. Here pollen grain wall is ornamented. Pollen ornamentation is present. Then maturity of sex organs. In wind pollinated flowers, protogyny condition, that means gynoecium matures first, and in insect pollination androecium matured first. So what is reason, what is logic behind this? If in in wind pollination, if androecium mature first, there is wastage of pollen grains. The gynoecium is immature, then there will be wastage of pollen grains, and to avoid the wastage of pollen grains, gynoecium mature first, and as soon as androecium mature, there occur the pollination becomes successful. Here the androecium mature first. What is logic? Because if gynoecium mature first, the insect will visit, but their body have no pollen grains, and therefore the pollination will be unsuccessful. To avoid this, androecium mature first. As soon as the gynoecium mature, the body of insect have number of pollen grains, and therefore the pollination becomes successful and easy. And therefore in insect pollinated flowers, there is a protoandry, that is androecium mature first, or a dichogamous condition, that means both androecium and gynoecium mature at the same time. In wind pollination, there is a protogyny condition, gynoecium mature first. In insect pollinated flowers, there is a androecium mature first, protoandry condition, androecium mature first, or both mature at the same time. In the wind pollinated flower, they are generally unisexual flowers. The bisexuality is common in insect pollination. So here unisexuality is common in wind pollination. The bisexuality is common in insect pollination. So these are the characters you have to remember about the abiotic and biotic pollinators. So characters of wind pollinated flower, they are very similar to the character of water pollination. They are very similar to the wind pollination. Characters of bird, bat pollinated flowers, they are very similar to the insect pollinated flower. So you study the maize as an example of wind pollinated flower, wind pollination. So here this is the male inflorescence, this is the female inflorescence. What you have to remember? The anthers are versatile. Anthers are versatile. They can easily move on this. There is no firm attachment, and they can oscillate here, and pollen grains are shed. They are transferred through the wind. The style is very long. The style is long here. Style is long and stigma is feathery. These characters you remember. Male inflorescence, female inflorescence. And you study the salvia flower as, so this is the salvia. Salvia flower as a insect pollinated flower. So here the corolla is bilipped. It is known as bilabiate corolla. Upper lip made up of 2 petals, lower lip made up of 3 petals. What is important here? The lower lip is large. It is made of 3 petals, and it is large, and it forms the sitting site for the insect. So this form here, insect can sit and the pollination occur here. So such type of flower it is present in Salvia and family Lamiaceae. So how to remember this? insect pollination and wind pollination comparatively. So here you may remember the wind, there are many nodes, and the insect having few yes. So here number, whenever there is number of flowers per plant, it is always many. Number of flowers per plant, it is few. Number of pollen grains produced, many. Number of pollen grains produced, few. The devices here there is no color, no nectar, no scent, no pollen ornamentation. Here there is a color is present, scent is present, nectar is present, pollen ornamentation is present. So if you remember, the wind has a many nodes and insect has a few yes, then you may remember the comparative account of wind pollination and insect pollination. And if you study the wind pollination, the characters of wind are similar to the characters of water, and characters of insect the much characters are very similar to the other pollinator, that is a bird pollination, or there is a bat pollinated flowers. You may remember like this. So thank you.